Welcome to another day on the Journey Shake Chem. Please do the 2 warm-up questions to the best of your ability, and I'll see you soon. Number 1, once again, asks for us to do the oxidation number of the underlined element. In A, we are looking for the chlorine in the chlorite ion. So I'm going to take this polyatomic ion out of the compound and look at it independently. Oxygen is -2. There are 2 of them. That gives me a -4. This polyatomic ion is equal to -1. Therefore, chlorine is +3. In the case of this phosphorus, again, I will take it out of the compound. It has an overall charge of -3. Oxygen is -2 times 4 is -8. The whole polyatomic ion is equal to -3, and therefore phosphorus is +5. Now, in the case of hydroxide, it is a polyatomic ion, but it is not written according to the rules that we normally follow, and that's just always been that way, so you just have to get used to it. So hydrogen in this case is +1, and the overall charge of this polyatomic ion is -1, and therefore oxygen is -2 like it normally is. So this also has an ending of IDE, and it's not following the binary compound type of naming. So it's an exception for hydroxide in a couple of ways. And oxygen in this case is -2. Now in D, I'm looking for the carbon, so carbonate has an overall charge of -2. And oxygen is -2. There are 3 of them, and therefore carbon is +4. Sulfur and sulfate. Sulfate has an overall charge of -2. So I set my equation equal to -2. Oxygen is -2. There are 4 of them. That gives me a -8, and in this case, sulfur is +6. Now, in this, notice this 2-2 ratio, and sodium is always +1, and there are 2 of them. So this portion gives me a +2. Therefore, this must be a polyatomic ion peroxide that has a -2 charge. Peroxide is -2, so I set my equation equal to -2. There are 2 oxygens, and therefore each oxygen is -1. And I can spot the peroxide when I see that it's with something that's normally +1 or always +1, so I can see that that has to be that polyatomic ion. And that's how you do number 1. Number 2 is to go from the names to the formulas or from the formulas to the names. Now, when we're given the names, it's very helpful to write the charge above the name. Nickel is +2. This Roman numeral is telling me that the oxidation number of nickel is +2. Nitrate is a polyatomic ion that I've memorized, and I know that that's -1. The common multiple between 2 and 1 is 2. So I must have 2 nitrates, because +2 and -2 is 0. Nitrogen, this Roman numeral, is telling me that nitrogen is +1. Oxygen is -2. The common multiple, again, is 2. So I need 2 nitrogens, N2O. In C, calcium, notice that there's no Roman numeral because calcium is an alkaline earth metal, and it doesn't need a Roman numeral because it's always +2. And calcium is +2, and acetate is -1. I still have to balance the formula to bring it to 0 because all compounds have to be 0. And so I need 2 acetates because +2 and -2 is 0. Now, when I'm given these formulas, first thing I have to notice is that lead is not an alkaline metal, it's not an alkaline earth metal, and it's not one of the silly 6. So it must have a Roman numeral because it can change, so I need to know what it is. Well, I look at the negative portion of this compound, and it's -1. There are 4 of them. That gives me a -4, and compounds must be 0. In that case, lead must be +4. So it's lead, Roman numeral 4, hypochlorite. In E, lithium is always +1, and dichromate is -2. That's why I need 2 lithiums in order to get this compound to 0. It's just lithium dichromate. And in F, sodium is always +1, and permanganate is -1. So it's just sodium permanganate. Manganate. Sometimes I have to spell them out to myself so that I get it. And there you have it. That's the answer to number 2. Now, today you will go over the worksheet that you had last night with your facilitator and get those answers. And if you're struggling with how we come up with the formulas, you might want to go back and watch that video on 173 that will tell you how to go through all of this process again, and review is always a good idea. So good luck on memorizing those polyatomic ions, and I can't wait to see you tomorrow. Bye!